Hi everyone, today our group Goodnight will present about number plate recognition. This our group member, me, I'm Wei Kang, Derrick, Tan Cheng and QUEK. So for the breakdown, automatic number plate recognition AMPR technology, also known as license plate recognition, where PR is a system designed to automatically capture and analyze license plate information from records. It utilizes advanced imaging and pattern recognition technique to extract alphanumeric character for license plate and convert them into readable format. So for the first breakdown is law enforcement and security, rapid identification and tracking of vehicle involved in criminal activity. So for second breakout is traffic management and monitoring, enforce traffic regulation and penalize violation. So for the third breakout is parking management, automate access control and try and assist procedures. So next objective, first objective is development and efficient and accurate AMPR system. Second objective is optimize image processing technique of plate detection. So the third objective is implement robust character recognition algorithm, and the last objective is validate and assess system performance. So for methodology, first is image capture. AMPR system use specialized camera to capture high resolution images of worker license plates. So these cameras are strategically positioned to ensure optimal visibility and image quality. So for pre-processing, the capture images undergo pre-processing steps to enhance their quality and facilitate subsequent analysis. Common pre-processing techniques include converting the image to grayscale, adjust contrast, and reducing noise. So for binarization, the preprocessor is then converted into a binary format where pixels are either black or white. This simplifies subsequent analysis and picture extraction. So for X detection algorithms such as the prefix operator and are applied to the binary image to identify the S of the character on the license plate. This helps in solution the license plate region. Next is localization. Using region perspective analysis, the AMPR system identified the bounding balls that encompass the license plate. This step involves analyzing the area and dimension of different regions to determine the most probable license plate location. So the next is character segmentation. The license plate region is further processed to isolate individual characters. It is achieved by segmenting the character based on their size, weight, and height. It involves removing small objects and separating the character for subsequent recognition. So it's optimal character recognition OCR. Once the character are segmented, OCR algorithm are employed to recognize and convert the individual character into their correspond alphanumeric values. This algorithm utilizes pattern recognition technique and machine learning model trained on the last data set of characters image. Post-processing and validation, the recognized characters are post-processed to remove any error and validate the accuracy of extracted information. Whereas the technical such as self-checking algorithm and context-based verification may be employed to enhance the reliability of the result. So lastly, for result output, the final recognized license plate number is presented in a text format, which can be further processed and stored for various applications such as security monitoring, toll collection, or parking management. After that is flowchart. First we start, then we read the image. After we read the image, we convert the image to the grayscaler. Then we invert to black and white color after we binarize the grayscaler image. Then we apply S detection using the prefix operator. After that, we find the location of number plate. Then we crop the number plate error. After we crop the number plate, we can read the cropped image letter. Then we can detect and compare the letter. After that, we store the detected letter inside an array. Then if all array are read, then we continue to calculate the accuracy. If not, then we repeat again this step, read the cropped image letter. After we calculate the accuracy, then we can display the output and the accuracy, then end our project. So now is the template creation for our project. So first, we read all the alphabet A until Z using the M read technique. Then we naturalize the number also using the 1 until 0. Then we're creating an array for our alphabet, also creating an array for our number. Then we combining our alphabet and number inside a single array. Then we save the combined templates after we create all variables.
Okay, so now I will continue to explain letter detection.m file. So here we created a function and then we load a new template, and then we need to input a sample image for our input data, and then we resize the sample image to 42 and 24, and then we compare the snapshot with each template in the new template array, and then we try to find the correlation coefficient between the resized image and the template image. And then now after we find the index, and then we use the index to identify which letter is the letter in the image. Okay, so this one is an explanation for the code. And then like just now I have mentioned, we need to resize the input image so that it can compare with the template image. And then the for loop is used to correlate the input image with every image in the template in order to get the best match. The metric read is created to record the value of correlation for each alphanumeric template with the characters template from the image input image. And then we use the find command to find the index with which correspond to the highest mesh character. All right, that's all for me. Thank you.
This pre-detection, we have five images, and we read the image and turn the image to grayscale, do the increment, and do the binarize, and apply the edge detection. We use the jump prompt to find the location of number plates, and we define the area as iProf area with this, and we count the iProf, and max A is the area, then bounded box defined as iProf bounded box, and this is the for loop, and this is for the all pixels. If max A is smaller than iProf area, then max A will be the current area. Then bounding box will be the current bounding box. Then we crop the number plate and remove the small object. Then we get the dimension of the crop image, show the image, and use the region prop again, count the iProp, and we create a number plate and for loops for all pieces. Then we count the length for the image, the first row and every column, and the length for all row and first column. If OW is smaller than h divided by 2 and OH is bigger than h divided by 3, then later will be the I cross image, and the number pair will be the number later. The ground truth for every image. Then we iterate over each character in the string for all number plates. For this function, we have three images here, and USD. In the first image, we did have present number plate JKN7B9L, but the ground truth is JKN789L. And the number difference is 1. The H become B, and the accuracy is calculated. And this also have difference. Pretended number is ELA, but the truth actually is DLA. And this accuracy. Then this is no different, means exact similar between predator number plane and ground truth. First image has no difference, and second image we have two different. The predator number is ABEB, but actually it's ABC123D. Result analysis, we have discussed why we have inaccurate results. It may be because the angle of the image and the font of the letter and character is different with the training image. In this training image, the tip is curly, but the testing image is not curly. And the letters look similar to each other. You can see in this example, okay, this 8 it look like the training image of B. And next example is E letter in training image is look like C in testing image. Since C in training image is curly.
Hi, it's me again. So now I will do the demonstration for our program. Firstly, you need to find the plat detection.m file and then you try to run it. Okay, so now let's see this example. Okay, so the actual value is AH72 and the predicted number plat is also AH72, which is exactly the same with our actual value. So the accuracy is 100%. Now let's go on to another example. Okay, so this is the second example. Okay, so the accuracy we get is 85.7143%. Okay, so there is one number of difference. Okay, it's supposed to give us JKM789L, but the predicted number plate is JKM7B9L. So this one, the actual value is 9, but when it do the prediction, try to recognize, you recognize the 8 as B. So maybe this one is due to the angle of shooting, or maybe the L is very similar to B. I mean how it looks like. So that's why he made the mistake. All right, that's all for my demonstration. Now I pass to QUEK again.
The conclusion, we learn new image processing techniques, edge detection, and major properties. An advantage is we can detect the number of plates, can recognize the characters and numbers, and crop the number plate. Disadvantage is the size of image is restricted, the color of number plate also restricted, and the angle of the image will affect the result. image cannot be too small. The decoration on the number plate will affect the result. The image must be taken with right in front of number plate. This is our reference by country P 2018.